Okay, so now let's get started. Today is the first day of the book club for the Spatial Data Science with application in R. So my name is Keuntae Kim. I'm a facilitator of this book club. So this one is, yeah, because I actually personally like this book because, and then I just tried to announce announce the book club to study this one together. So do you have a are you the first time to join this kind of book study group, or do you have already do you do you already have experience to the book club before? Okay. Okay. Mm, so okay. So so now that everyone knows about how this thing goes. So okay, so I'm gonna briefly just explain about this book meeting and then try to move to the chapter one. Okay. So today is just kind of, as I said, the first day of the book club, and then we will, from now on, we will start studying the spatial data science in with application in R by Edzer Pebesma and Bivand. Actually, these two authors are very famous about the spatial data analysis because I have another book of theirs, like applied spatial data analysis with R. That is also one of the very best book for the spatial data analysis. But the thing is that that book is a quite challenging and then quite difficult to study because it actually includes a lot of equations and some kind of formula because that book usually focusing on the how spatial data analysis actually work. But I personally think that this one is also kind of a little bit tricky, but the thing is that this one is others try to explain the spatial data science as easy as possible. So that's what is good about this book, and also this is the most recent latest book they published. So and also unfortunately they also providing this book online like this. So it is also another good way to it is also good for us to learn this one for free. So that's the kind of thing. And then so as you all know, we're gonna try to present a chapter per week, and then just kind of using this kind of like a book slide share link, and then by using the art book down, and then we can try to present some of the chapter. Because now we have actually this book consists of 17 chapters, so hopefully we can try to finishing this book in 17 weeks. Assuming that we're gonna we're gonna study one chapter per week, and then the other thing is, yeah, like I said, it's a one chapter per week, and then sometimes maybe there's a too much content within that chapter. Maybe we can split the chapter, and then we will try to meet every week. And then, but depending on everyone has their own life event and then everything. So if you can, if you can let the other members know that, and then maybe I will try to thinking about the meet the other week, or just arranging the meeting schedule. And then also when you click at the top, when in the Slack in our book club website, when you click at the top, you everyone can see that Google spreadsheet file. Okay, so when you see this, you can actually feel free to I would say feel free to put your name because the chapters you wanted to present. So just feel free to fill out your name on it, and then in that week you will have an opportunity to present the chapter and then lead that study group sessions. Okay, so do you have any questions so far or anything?
No questions from me at the moment.
Okay, thank you. And then now let's get started. Okay, this one is not right. Okay, hold on. Let's share my screenshot of this. Okay, so hold on, how this? Okay, so anyway, uh, so everyone can see the screenshots, right?
Yes.
Yeah, and then also because I don't know why I cannot show you the preface part of this, but okay, I'm gonna just share the book instead, and then I will try to explain to do that. Okay, so this one, as you can see here, this is actually book the link website of the book link, and then so it's about the spatial data, like in here underlying spatial data, like a point, line, and polygon, and then raster, coverage, geometry, attribute, and data cube and reference system. Also, some kind of very high level complicated concepts depending on our research questions. And then they actually kind of listing a lot of packages we can we will learn throughout this book, like SF and maybe tidyverse is just kind of a data manipulation tool, so we also can learn that. And then special like for the special data regression model, and then SPDEV is also one of the famous one. And then a map view and tmap is a kind of like an interactive mapping visualization tool, packages, I mean. And also SpecStat is a one of those very famous and commonly used tool, because I actually use these kind of tool for the special point data analysis. Oh, okay, gotcha. So can you see now a little bit bigger? Is that good? Okay. And then also everyone can see my writing like this.
Yes,
Okay.
we can see the annotations.
Okay. Ah, good. I cannot erase yours, but okay, it will be fine. So these are the kind of tool we're gonna study. So, and also there is actually more than this, our package is more than this one. So when you check about the clan view, I think you guys already know this. When you Google the clan view, and then when you click the special, maybe I think the special analysis, there might be the whole list of our currently our packages available in there. And then I think there is a function to, yeah, there is also a function to kind of like installed all of those kind of tool by using the one single command. I just forgot that, but maybe if you are interested in it, yeah, you can feel free to check that out. Yeah, like this. So here is the kind of everyone can see the screenshot, right? So these are the kind of screen the list of the brief list of the data, spatial data R packages, and then I think that there is a command to install all of these packages at once, but I don't yet here like CTV install view this one, but do not try this because this one actually installed all of the our spatial data analysis R packages in your computer, so they're gonna be increase your computer kind of like a processing burden. So don't do that. And then this document is also very useful, contains very useful information about what kind of R packages you're gonna use, like spatial data in general. Because in here, especially I wanted to point out is we already know that maybe SF is the common spatial common R packages that deals with the spatial data set. But before SF is produced, there is also another package called SP package. I think that you guys already heard about this one before. So, because SP package is another packages used before before SF was launched. But sometimes, especially in my case, I sometimes use SP because some of the data, spatial data analysis, especially for the spatial point pattern analysis, POINT, spatial point pattern analysis. When I try to do that, actually some of the R function for the spatial point pattern analysis actually still use the SP data frame format. So in that case, we have to convert the SF data set to the SP form. So it sometimes may happen, maybe depending on what kind of a spatial data analysis you're gonna use, especially in my experience. Spatial point pattern analysis sometimes use the SP format. So especially for for example, like a Poisson point pattern point processing model or inhomogeneous Poisson point process model like IPPP. These kind of spatial point pattern analysis actually still uses the SP format packages. So in here, this book mostly use the data set based on the SF format, but some of when you're looking at the other spatial data analysis book, especially for the maybe a little bit older one, you can find that they still have using the SP format, and also you can still download the SP packages to use the spatial data SP type of the spatial data format. So that's the kind of thing. And then next one is just kind of it's just kind of a simple introduction about how they gonna do this. So that's it. And then okay, and then I will share my screenshots. Okay, So first, here the first chapter actually covers the very brief introductions about what's the spatial data look like, and then what kind of things we gonna learn throughout this book. So it is just kind of a overview about the book in this book. So in the chapter 1.1, they actually introduce the kind of a very directive introduction of how we can create the first map. So in here, by using the SF function and then the tidyverse, and then GPKG is a kind of like it is a geo package file, right? So usually we can use these kind of a file set generally in QGIS, I guess. And I'm not sure this one can be also imported into the ArcGIS because I never done that before, but definitely QGIS actually QGIS can import this kind of a geo package file. Geo package file is a kind of like a file of the multi type of the geometry. Like it can contain point and polygon and raster, etc. And at the same time, with the attribute related to each geometry. So in here, what does that thing is just kind of open this geopackage file and then read as an SF file, and then that actually gonna be NC, and then EPSC 3211 line is a kind of like a coordinate system that defined by this one is the net 27, I guess. So once we get this SF data set, we're gonna try to define our projection for that spatial file is about. And then in here, what does the things is just selecting the birth in the number of birth in 1974. Actually, by the way, this NC data set is kind of like what is called the seed data file. Seed data file for in North Carolina. What is mean by the seed is the sudden infant death data set in North Carolina about 50 years ago. So anyway, so it selects the column called birth in 1974 and then try to plotting this one as a map. So our outcome is like this, and also at the bottom there is the kind of a legend to the continuous legend about the gradient of the colors from the blue to yellow. So these are the kind of like a very basic kind of steps we use when we try to do the first time to conducting the data analysis, like exploring the spatial pattern of our attribute, our comparable or our relevant independent variable before we conducting the more advanced spatial data analysis. Okay, and then not this, and then when we scroll down in here, there is a geographical elements presented. So polygons are drawn, like a polygon like these things is drawn, and legend is at the bottom. And then the background of the map actually have a kind of shows about the latitude, longitude, and latitude of the locations. Actually, the reason why this curve is a little bit curvy, this line is a little bit curvy line is because of we set up our coordinate system as a net 7 kind of a project system. So that's the reason we can have this kind of a curvy line. And then yeah, like this axis sticks actually shows the latitude and longitude values. But by the way, actually, at the this one at the top shows about these are actually our code that this book actually presents. But the thing is, there is also another way you can do using this kind of creating this kind of a map by using the tidy census and Tigris package. This one is I just create the code, because in here actually contains about what is called the census data set. Maybe there is another package called the tidy census, which allows us to directly access to the census data set in the US Census data set. And then there is actually a function called get ACS. And then we can, by using these functions, we can select the geography. And then variable, this one is actually, there is a whole list of the variable list with the code like this, and then with the descriptions. Have you heard of the website called NHGIS? When you check this website, you can find out this kind of a census data set, and then you will also find this code in that website. And then actually this code actually about the median household income. And then states, you can actually set up the states, and then a year and geometry is true. And then when you're plotting this one, and then show this kind of a result. Or maybe you can use the ggplot to map it at the by using this code, and then you can get this code at the bottom. And then this in the chapter 1.1 also explain about what the data structure is look like in our data set in the above sample. When you try to check out the property of this variable this object, you will see this kind of a result. So that means it has the table is kind of a table, right? So this one is actually what is called the attribute table, right? In the GIS. So this attribute table says about we have 100 county level information in this case, and then four columns, and then four 100 rows for as a table. And then the bounding box is a kind of like when we have this kind of map like this, it actually defines about the boundary, like x minimum is right here, and then y yeah, like x max is here, maybe y max gonna be here like that. So by defining this maximum x and y location point, we can actually define the boundaries that contains this mapping result. And then geometric type is a multi-polygon, which is we have a lot of different kind of a county shape within county shape. So this is the multi-polygon with the attributes like a data frame. So, and then also when we looking at the CRS, like a coordinate reference system, that is actually not 27 going to be used, because we already set up this one by using the EPSG kind of a numbering code. So this one is how spatial data structure look like, basically. And then we can actually also, this one also shows about a more complicated plot, like if we have a multiple time series data set about the death or maybe birth in this case, we can try to select the multiple column like this. And then we can pivoting to the longer format. What about the longer format is maybe we can get the year column, and then maybe we can have a seed value like and also county code. So maybe each county has the 74 and 79 birth number like this. These are the kind of a long format. And then pivot longer is allows us to transform to the pivot wide format into the long format. And then by using that long format data set as a time series data set, we can develop the map like a result at the bottom. And then we actually processing this map based on the here is kind of a name in here. And also label is the year label variable. So because up to the top, here is the 1974 and 1978, and then 79 and 84. And then we can get to these two map based on the year, and then the county and then the different counties. So that's how we can try to do another more complicated plus, but depending on our data set structures. And also maybe if we wanted to do another very interactive plot, we can do this by using the map view. Map view actually allows us to have a more dynamic mapping like this. So when we run the R code above, and then when we run this, we can get this kind of result. Compared to the plot result above, interactive map actually allows us to the more dynamic kind of a data exploring. Like when we click one of these counties, we can get all of the relevant information related to this county. And then we can also feel free to move out and zoom in and zoom out. And also we can change our map theme like this based on the map view default option. And also at the top right, we can also see the attribute that we just plot on this. So these are the kind of more useful and more interactive example about the mapping. So any questions so far? Anything? Okay. So let's move to the next one. So next one is actually talk about the coordinate references system, because in the previous chapter we actually defined the project coordinate system before we plotting the map. So here is the question is, are the map view and leaflet is the similar and different? Actually, I would say leaflet and map view is very, very similar. And TMAP is also very similar, because they all kind of suppose the more like interactive mapping things. But leaflet is more kind of based on the more element-based kind of approaches, because by using the leaflet, you can just kind of define what is called mapping widgets that you want to customizing. But map view is just kind of a very, very simple, most simple and directive way to get the interactive plot. But leaflet allows you to have access to the various type of the mapping widget. That's what I know about. Like more like a customizable kind of a interactive mapping plot and visualization packages. Yeah, because leaflet leaflet is actually available in Python and R and JavaScript, etc. So, but the thing is, in the leaflet, it's more like widget-based kind of approaches because more customizable. That's what I understand, I guess. Is that answer to your question?
Oh, yes, thank you.
Yep. And then the second chapter, 1.2 is the mention about the coordinate reference system, because we actually project the code before the mapping, and then we definitely define the locations before we creating the mapping, or even the weekend before we learn the spatial data analysis. We still need to be defined our coordinate system, because in that coordinate system actually define about what is called our unit of scale and unit of analysis, like meters or square meters or miles or square feet or square mile, etc. So depending on these kind of units, we can actually interpret our result depending on these kind of units. So coordinate reference system is a very, very important. So there is in here book actually introduced the two major types of the coordinate system, like ellipsoidal coordinates and the projected coordinate system. I actually found Googled this coordinate system figures, and then I just presenting in here. Ellipsoidal package is a kind of a degree latitude and longitude. So like a minus 37.47896.4, and then 89.915687. I just randomly devise this one. So these kind of a latitude, longitude, and latitude is a kind of representing the x and y axis, and then based on that, we can actually exactly define the exact locations. This one is actually two-dimensional, but in this case, in the figures, we have x and y and z if we have a three-dimensional kind of a mapping. Okay. So this one is actually what we usually saw when we check on the Google map, right? And then whenever you click the sum of the location, you can get these x and y coordinate informations. So that is actually ellipsoidal coordinate system, like a latitude, consisting of the latitude and longitude, and then exactly pointing to their locations. But the thing is, depending on how accurate the decimal number of the decimal level actually defines the level of accuracy. So usually in the Google Map actually serves the decimal level down to the 6 decimal level, like a 6 decimal. I think this one is kind of like accuracy is like a 2 meter or 5 meter kind of accuracy. That's what I know about. Maybe there is some cases you can have maybe 4 decimal level or even maybe 3 decimal level, etc. So in that case, less decimal level gonna be less accurate result of the locations. So that actually how many decimals and actually determines about the level of accuracy of the locations. Usually we have a 6 decimal level for the exact locations, like in Google Map. And then the projected coordinate is the kind of we just try to coordinate into the flat 2-dimensional coordinate system when we're plotting the map. So in here at the bottom is an example of the things, like we can actually plotting the spread out to the coordinate based on the cylinder. Like we try to like how we get that, like reflect those kind of coordinate locations into these cylinders, and then when we try to spread out as a flag, we will get this kind of system. These are the kind of coordinate system is when we looking at the world map, and then in that case we will have this kind of a coordinate system. And also conical is we can actually projecting our three-dimensional Earth surface into this cone shape of the coordinate cone system, and then we will get this kind of a like a fan shape kind of a shape. And then the planar is we can actually projecting the all of these things is the circle. And then when we flat out, we will have this kind of a circle. Okay, so these are the kind of simple definitions about the projected coordinates. And what is the good thing about the project coordinate is maybe, for example, in the NC North Carolina cases, we will really want to get an exact location and then get a very good geographical information about the North that reflects the location of the North Carolina. We usually use this projected coordinate system compared to the ellipsoidal. Ellipsoidal is more like a worldwide kind of a universal standardized kind of a coordinate system. And also cylindrical also have a kind of a very standardized kind of a worldwide kind of a coordinates. But compared to the conical kind of system is kind of have an advantage about when our spatial scope is just kind of specifically looking at some very small areas, and then we will try to looking at that small area like this part, like this. In that case, this coordinate system can have a big advantage allows us to get the more accurate locational factors, locational kind of information. So that is actually what is called the state plane coordinate system come from, because in the US we will actually have a NC or maybe Georgia or Utah, etc. kind of a coordinate system depending on the different states. And then even in the Utah where I lived before, there is the kind of a different state plane coordinate system. One is the North Utah, the other one is the Central and South. Because the Utah is the kind of this kind of a shape, so it is kind of longer to the north and south side. So Utah, in case of the Utah, there is a kind of a north, central, and south. In case of the North Carolina, like this kind of a shape, I think they have a east, they have a west and east kind of a coordinate systems, like a state plane. So this state plane coordinate system is one of the typical example about the projected coordinates. Okay, so what is the good about this projected coordinate system is that this one is actually give us a very good locational accurate locational information when we have a very smaller spatial scale or sample kind of map to analyze. So these are one of the typical example of this. So do you have any questions so far? Anything? Okay. And then the other type about this one is what is called the raster and vector. Oh yeah, it is this typo, like a vector data. Like a raster data is a kind of like information of the unit grid scale kind of information. So each grid cell have the information about some specific attribute. Like for example, like in this case, this might be have a temperature. In this case, so we can divide all of this information like basic shells like this, and then we can have these kind of each cell has each as raster values, and then when we have the other raster cell image called elevations, maybe we can actually calculate these by using these two different raster images. We can also try to manipulate the raster value, the raster data set by using the overlay or intersect or multiple or maybe subtract, etc. Like a numbers. So that's what is the good about the raster images, right? Like this. Yeah. What is the good thing about the raster is we can combine these two different attribute information into the one single kind of raster images. And then definitely we can also allow spatial data tool, and then R also allows us to convert the raster to vector and vector to raster conversions. And then this one is we will cover about this one in the later section. So just to keep in mind, raster is defined about this kind of a grid cell with the values, and then maybe if we have a multiple raster images, we can calculate these multiple raster images into the one single result raster image output. And also we can convert the raster to the vector and vector to the raster conversion. Okay. Any questions? Anything? All right. So next one is talking about the raster type. So in the previous sections, we actually saw what is what called the regular things. But depending on our coordinate system, we can get some of the rotated or shared or curvilinear and rectilinear images, depending on our coordinate systems. And then that coordinate system actually have a very size of these grid cell, depending on those kind of coordinate system locations. So it is just kind of depending on the geometry kind of system, we can get all different kind of a grid cell. But usually one of the commonly used about the raster image is kind of a regular kind of a rasters. So, and then the 1.5 is talking about the time series analysis, because right now currently we have to looking at the spatial location data set, but it also has the temporal data set. Like when we create the first map, and then when we try to looking at this facet at the bottom, this one actually have a spatial at the same time the temporal kind of information, right? So in this case, each polygon can have a spatial and temporal kind of information. So in this case, we have to do what is called the spatial temporal statistics. There are also R packages that allows us to conduct the spatial temporal statistics. I think we will cover this one in the later sections. And then in this case, what is the complicated about this one is in case of the spatial data analysis, the only thing we can thinking about is just thinking about is testing the spatial autocorrelation, right? Like how similar or different in the each neighbors is about, like testing these autocorrelated result effect. But in case of the spatial temporal data, we have to testing the spatial autocorrelation at the same time the temporal autocorrelation testing, like a Dublin-Watson kind of a testing for the autocorrelation test. If we have a significant kind of a result outcome for the spatial autocorrelations, we have to try to consider both in terms of the spatial temporal statistic. For example, like a earthquake kind of a data set with multiple times in some country. In that case, we will have a spatial and temporal information. So in that case, we will have to, our data set is very complicated, and then our approach is also going to be complicated. We will cover this one maybe in the later section of this book. And then the next one is what is called the support. Support is just kind of a special area attribute value. So that means when you have there is a polygon, and then each in that polygon has a set of the attributes like a birth and death, maybe total populations, or maybe land use type, etc. This one is all of the support. Like attributes related to the each geometries. So, or maybe we can say that in the polygon, there is a multiple point like this, and then each point has another attributes, and then these kind of aggregate point result also can be considered as a kind of a support. When we aggregate the point data set, and then to get the one attribute table, that is also another type of the support. So support is the very important when we try to manipulate the data set, especially for the spatial data analysis. We sometimes aggregate the multiple points within some specific area into the one aggregate result to be as a polygon. Like for example, there is the light rail transit station in here, and then there is a lot of business location nearby the LRT stations. Maybe we can thinking about depending on our walking maximum walking distance, like a quarter mile. Usually maximum walking distance is a quarter mile, and then try to making the quarter mile circle buffer, and then we can capture this kind of a business within that buffer polygon, and then that gonna be, we can aggregate this kind of a point as a kind of a number of businesses at total, or maybe number of businesses by industrial sectors in this case. So in these things is all of things is about the example about the support. Okay. Any question about the support so far? Anything? Okay. So, and then the final one is kind of like from now on, the final section of the chapter 1, the author talk about the spatial data science software available in R. Like in here, actually, authors talk about all of the relevant R packages based on the SF, because SF is the most commonly used spatial data analysis, spatial data format recently, nowadays actually. But the thing is, like I said, there is still some of the packages still requires what is called SP format. So just to kind of keep in mind. And then based on the SF, there is a 275 CRAN packages, I think more than this. And then stars and NC Meta or LWZOM, DBI. Yeah, DBI is also very important packages. Tidyverse is the basic data manipulation tool. And then GEOS and project is allows us to the reprojection and then data transportation. And GDA is also kind of a most important spatial data packages that allows us to the manipulating and processing the geodata tool under the 100 plus different libraries. And also there is also many other tools available in R. And then from the next chapter we will start studying these kind of packages depending on our research question or examples that we have right now. So that's the end of the chapter 1. And then do you have any questions so far or anything? Okay, so this is the chapter 1, and then now we have to thinking about maybe who gonna do the next chapter 2 for the next week. So
I
do you
was
have
thinking
any?
about that, and to be honest with you, but this is my opinion. I don't know what others, and we can put it in the Slack channel too, but I feel like the chapter 2, which deals with projections and coordinate systems.
Yes.
I feel like that's the trickiest thing about spatial analysis.
Yeah.
So to me, I'd much rather have someone who understands spatial projections and who understands coordinate systems very well to present it. And I feel like that's you. But I promise you, I can help with other chapters. It's just that chapter 2, I feel like it's because it's this thing that's it can be tricky, right? And I know the basics, but I don't know it as well as apparently you do. You just gave a lecture on spatial analysis right now. So that's my opinion.
Okay.
Yeah.
Okay. So maybe if there is no volunteer to do the chapter 2, maybe I will do that. And then maybe just like I said, in the Slack, in our book club Slack channel, you will find at the top, you will see that there is the volunteer spreadsheet file, and then you just feel free to looking at those chapter title and chapters, and then just feel free to put your name on it, and then the chapter you are interested into the studying, and then you can put your name on that. Okay.
Yep, sounds good.
And then any other things? Because I think that we have another person here, right? Yeah, like Derek. You have any thoughts or any questions?
No, I do not have any thought. I think I also align to what Gabby is saying because coordinate reference system, I think I also align with our submission about the coordinate reference system.
Okay. Yeah. Yeah, I also think that the coordinate system is one of the trickiest part. And also it is still hard for me to explain about this coordinate system actually. But okay, I will try to do the chapter 2 for now. Maybe if there is any other volunteer, maybe I will hand it over to him or her. But right now I'm gonna try to do that one, and then I will try to do my best to explain the coordinate system as clearly as possible in the next week. Okay.
All right. Thank you, Keuntae.
All right. So
Thank you.
this is the today. So and then I will see you all next week, and then we will cover chapter 2.